Lesson 2.9, absolute value functions. Recall that an absolute value function is a function whose rule contains an absolute value expression. We have what's called a parent absolute value function, which is just the f of x equals the absolute value of x, and it has a V shape with a minimum point or vertex at 0, 0. So looking at the parent function, that's nothing being done to it, no transformations, no minus x, no minus or plus outside of the absolute value, just plain absolute value of x. When you look at the graph, you see that the vertex is at 0, 0, and it makes a V shape. It has two linear pieces, one with a slope of -1 and one with a slope of 1. Okay, in our lesson 2.6 in the prior sections, we transformed linear functions. We're going to do the same thing now to our absolute value functions. So, translating an absolute value function. Let g of x be the indicated transformation, which is f of x equals absolute value of x. So write the rule. So 2 units up. Recalling our prior lessons, when we went up or down, we added it or subtracted it outside of the parentheses. So we're going to do the same thing here. Outside of the absolute value function. So I don't do anything to that. 2 units up means I'm going to add, so I'm going to do plus 2. Graph the parent function. And then graph g of x. And it's moving 2 units up. Left or right goes inside the parentheses. So remember, our basic rule is subtracting if it goes right, adding if it goes left. So I would add 3 units. So what does that look like? Parent function in blue. And it's going 3 units left. So what's happening is the vertex is moving to the left 3 units. Okay, so pause the video and try the next 2. Remember, up or down goes outside the absolute value, left or right goes inside. Right will be a minus, left would be a plus. The first one is going down, so it goes outside the absolute value, and you just subtract 4. So the vertex is moving down from 0, 0 to 0, negative 4. The second one two units to the right. It's going to go inside. Oops. It's going to be minus. And it just moves the vertex 2 units to the right on the x-axis. This is very important because the entire graph moves when shifted. That's what determines the vertex of an absolute value function. So pay attention here. The graph of g of x equals x, absolute value of x minus h plus k. The vertex would be at hk. Keep in mind it must be a minus inside. So if it's not a minus and it's a plus, you would have to change it to x minus negative h plus k. So then the vertex would be negative h k. And likewise, if the plus sign for the k was a minus sign, then it would be opposite. So we're going to translate f of x equals absolute value of x. So the vertex is at negative 5, 3. So here's my h, here's my k. So what would the new function be? Be the absolute value of x minus h, which is negative 5, plus k, and since k is positive, it's going to be plus 3, which is the absolute value of x plus 5 plus 3. So graphing that, let's graph our f of x first. Parent function. And then our g of x, which I know is at negative 5, 3. Negative 5, 1, 2, 3. G of x. You have a couple to try. Go ahead and pause the video, or you have one to try. Go ahead and pause the video and try that. You should have got that the translation was the absolute value of x minus 4 minus 2. And then graphing that very easily, you just plot the vertex and keep that slope of 1 and negative 1. Okay, so they were the easy ones. Now when we stretch or compress or reflect, again, we do the same thing that we did with our linear functions. So the first one is that we're going to reflect a graph of the absolute value of x plus 2 plus 1 across the x-axis. So I put your remember thing, a reflection across the x-axis negates the whole function. The whole function. So negates so it would be the negative absolute value of x plus 2 minus 1. The vertex, here's your h would be negative 2, your k would be 1. So go to negative 2, 1. And because it's negative, it's just going to open down instead of opening up. What would f of x look like without that? It would just have the same vertex. Excuse me, except it would open up. and that would have been your f of x. Let's try a stretch. There's your remember how to do stretches and compressions, horizontal and vertical. So this one says to stretch the graph vertically by a factor of 3. So what happens when I do a vertical stretch or compression? I multiply the whole function by the factor. Okay, so what does the f of x look like? Well, it would be at 0, negative 2 would be the vertex, and then you would have to just substitute some values in there. When I substitute a 1 in there, I get negative 1. Put a negative 1 in there, I get negative 1. 2 in there, I get 0. So it still looks like the same positive 1 and negative 1 slope. But then a stretch, Wells Fargo agreed to pay $185 million. A stretch, put some values in there. I put a 0 in there and I get 3 minus 6 is negative 3. I'm sorry, 0 minus negative 6 is negative 6, my bad. Put a 1 in there and I get negative 3. Negative 1 in there, I get negative 3. Put a 2 in there and I get 0. Negative 2 and 0. So it looks something like that. So you have to maybe substitute a few values in for the absolute value in order to find the points. And you see that it's coming closer to the y-axis. What if I want to compress it horizontally? Horizontally now, and a factor is, it goes with the x. So it's the 1 over the factor. So 1 over 0.5 x minus 1 minus 3. 1 over 0.5 is the same as 2. So it would be 2x minus 1 minus 3. Okay, and again, to graph this, you would have to graph a few points. Just put some numbers in there. I'm going to put a 0 in there. I get negative 1, which is 1. And 1 minus 3 is negative 2. Put a 1 in there. I get 2 minus 1 is 1. Minus 3 is negative 2. So that tells me that the vertex is in between here. You could put a 2 in there. 2 times 2 is 4. Minus 1 is 3. Minus 3 is 0. So it's going to look something like that. And you're welcome to graph the original function if you want. The original function is just going to be spread out more. Okay, so you have 3 to try. 3 to try. So pause the video. Try to at least write the function. I can understand if you have trouble graphing, and I'll be okay with that. I wanted to see that you can definitely write the function. When you reflect across the y-axis, if you look at your rules, you only negate the x. Everything else stays the same. So I'm going to graph f of x, and I'm going to graph g of x, so that you can see. I'm going to use 0. If I put and I put a 0 in the original function f of x, I get 0 plus 4 is 4, negate 4, get negative 4, plus 3 is negative 1. I put a 1 in the original function, 1 plus 4 is 5, negate 5, I get negative 2. Put a negative 1 in the original function, I get 3, negate 3, I get negative 3, plus 3 is 0. I'm going to graph those points. 1, negative 2, negative 1, 0. Need a few more. I'm going to try negative 4. Negative 4, I get 4 plus 4 is 8. Negative 8, get negative, sorry, got to put it back up here. The f of x, negative 4 plus 4 is 0, and 0 plus 3 is 3. And that will be the vertex. The g of x can do 0. 0 plus 4 is 4. Negate 4, you get negative 1. So you can see they cross at the same point, and they should if they're mirroring across the y. You should see if negative 4 is 3, positive 4 should be 3. So it should look like that. And you can check that. Put a 4 in for x. Negative 4 plus 4 is 0. 3. Trying the next one. Compress vertically. When you compress vertically, you take the factor times the whole function. And I think we're going to forego the graphing portion and just, can we come up with the new function? The same with stretching horizontally, because these are a little bit more complex functions. Stretching horizontally, what do? We divide the x, or multiply by 1 over b, which is the same as just dividing by b. So I'm going to be okay with, can you write the function? How does a vertical translation affect the graph of an absolute value function? Vertical translation moves the vertex up or down. How does a horizontal translation affect it? Moves the vertex left or right. How does the process of stretching an absolute value function compare to that of other functions you've seen? And hopefully you've seen that the process is the same. Again, focus on being able to write the transformation in this section. The basic f of x equals absolute value of x. You should be able to graph the transformation, but when you get into the more complex problems, I will not be too concerned with you being able to graph. Have fun.